All right. So I wanted to have a talk about promises and kind of walk you through like what is a promise? How do you use a promise? Someone on my Discord asked me if I can kind of just like give a good overview of promises because he's still kind of confused about them. And it is kind of a confusing concept to kind of understand when you first learn JavaScript. So let's just try to walk through what a promise is. Okay. And I would definitely recommend read this like documentation. It might be a little dense, but it does have some good information in it. I could put this link in the description of the video. But anyway, I think one of the best ways to kind of learn about promises is to first of all play around with promises. So a promise is a kind of like a object that has a dot then method and a dot catch method, right? So you probably have seen this when we've done fetch or you've done Axios or anything else that does asynchronous calls, where you have the ability to call a dot then to basically run some code when something finishes. Okay, so like I'm gonna start with the most basic example with a set timeout, which is a function that is going to be invoked after a certain amount of time, right? So in this example, after 1 second, we can have it print out hello world. Okay. And what we can do is if we were to run this code, after about a second, you'll see it print out hello world. Nothing too extravagant there. But if you want to take this asynchronous code and you want to wait for it to like finish before you do something else, let me show you real quick. I'm going to print out another message here called like GG. And before I even run this, what do you think is going to happen, right? Do you think it's going to print hello world and then GG, or is it going to print GG and then it's going to go back and run this asynchronous code, right? Well, let's just run it and you'll see that it prints out GG first, because the way the call stack is working is it runs through this, it binds this to the event loop of Node or JavaScript or whatever. If you're using the browser, it'd be like the V8 engine in the browser. And then it's going to run this, and then it comes back and it actually runs this after a second, right? So step one is it binds the timeout to the event loop. Step two is going to run down here and it's going to print out the console log GG. And then step three, it actually finally gets into this callback and invokes it. So the whole idea about promises, like before I dive into like what a promise is, why do we have promises? Okay, so if you go back and rewind history a little bit, the main reason we use promises is because there's something called callback hell, where the only way we used to be able to deal with asynchronous code was you'd have callbacks inside of callbacks inside of more callbacks. And I'm just kind of, copying and pasting some silly code, but you'd actually have code that would look like this, right? You have to call an API, wait for that API to return, and then you have another callback to invoke another API. You'd wait for that one to return, and then you invoke yet another thing, or maybe you need to write to disk, right? So then you have to do another callback. So your code could easily turn into something like this. And there's like workarounds you can do to like try to clean it up, but it was always a mess, right? There's never a great way to like get around this. So someone, I don't know who invented promises, but someone pretty smart decided, you know what, maybe we can just wrap all these callbacks in something so that we can actually start like chaining these things together, right? So that's where promises come in, and I'm going to kind of show you how you can use a promise at a high level. I do have some code here where I wrote my own promise class, which is going to be pretty advanced, so I'll save that for the end so I don't lose you all at the beginning. So again, like let's say we wanted to run some asynchronous code. And again, like what does asynchronous mean? I don't know if I mentioned that. It's code that runs and finishes at a later time, right? So for an example, hitting an API endpoint, that might take a second, 2 seconds for the results to come back. So in nature, that's asynchronous. Versus synchronous code is something that would run like in order sequentially. So yeah, I mean, we could do an example with fetch if that would kind of make more sense, but let's just try to use a promise and, see what this changes, okay? So in JavaScript, there is a class called promise. And it turns out like we used to actually have to install a third-party library called like Bluebird to actually get promises. But if you do new promise here, this is how you construct what we call a promise, right? This thing takes in one argument that happens to be a callback. So this callback takes in 2 arguments. It takes in a resolve and a reject. So the whole idea of this promise is you can put that asynchronous code and put it like right inside of that callback. And whenever that promise is done, or sorry, whenever that asynchronous code is done running, what you do is you just want to resolve to tell the promise that, hey, like this timeout is done. Or if you're using fetch, another example could be, fetch isn't really a good example because it's already using promises. But if you're using like XHR requests, like, let's see if I can find an example. XHR example JavaScript. So going back a long time ago, this is how we have to like create requests. We would actually have to like create a request object and then like add an event listener and then like send it. And then at some point it would be done. You have to like listen to it and check the status code. I don't know if I just went off the deep end on all that, but like this uses callbacks, right? So it's super ugly to mess with, versus if we had promise support, then it wouldn't be as bad. So if you imagine this could be anything, right? This could be like a node fs write. All right, let me stay focused. Sorry, I'm like jumping around. So we have this idea of a promise that we can create by passing it a callback. And again, like I said, like whatever's inside this block, no, I'm just going to set this equal to a variable here so we have less like red errors everywhere. Sorry, I have error lens set up, which kind of like highlights all my code in red when there's an error. It's kind of distracting for teaching, but it helps me really figure out when there's errors really quickly. So anyway, this callback that we pass to the promise, it's our responsibility to make sure that we call the resolve at some point, right? And what this resolve does is it basically allows you to chain on other promises to your original promise. So if we want to basically get the value of whatever is resolved, let's just go ahead and get like a value here. And I'll just go ahead and console log something like hello world, or say hello and then comma value. Okay. So if I run this, it's going to print out undefined probably. And the reason it prints out undefined is because whatever you pass into this resolve value is actually going to be passed into the next .then that you attached to your promise. Does that make sense? So if I were to pass in like 50, value is now going to be 50, right? Because how a promise works is you can keep on tacking on .thens to it, and then you get the values that were resolved before. So this is kind of not a good example of set at timeout. It's usually a better example with like an asynchronous fetch request because you get real data back. But the idea is the same, right? You're just resolving some arbitrary data, and then the .then has access to whatever was resolved. Now let me also show you. I can do the same thing. I can have different .thens all attached to the top level promise. And if I do like 1, 2, 3, you'll actually see this print out 50 3 different times. Okay, so it prints out 1 to 50, 2 to 50, and 3 to 50, right? So it's kind of like a pub sub where like you subscribe to the promise, and then when it finishes, it calls these callbacks all at the same time. Well, not at the same time. It's going to be sequential because node is single threaded, but you'll see that you get the exact same value. So this is not promise chaining, but let's say you wanted to do some type of promise chaining, which is a term that I haven't really talked about, where you have a promise and you need to do something with the value that gets back, but then you need to again fetch some more data from an API. Okay, so you can do something called promise chaining, where you can actually tack on another .then to your promises, and whatever that the previous promise resolves or returns. So if I were to return like hello, this value here is actually going to be hello. So let me run this real quick, and you'll see at the bottom it prints out 50 and then it prints out hello. All right, so something that's cool about promises is that everything that you put on the .then, it's going to automatically wrap it in another promise. So this is going to be hello, and it's going to wrap this in a promise so that you can do a .then chain on it and get the value of that hello here at, you know, line 87 at this point. And you can keep on doing that. You can keep on tacking on stuff. And typically what people do is they'll have a promise and do a .then, and they'll do like another promise. They'll return another promise, right? So I'll do like another fetch from, I don't know, I'll do like google.com. And the thing that's going to be in value after this promise chain is actually going to be another promise. So if I were to console log this, I believe it's say like promise down here. Now I do believe this is a promise. Let me just double check. Like if I were to just console log the .then here and run this, I think it's going to be the same code, promise pending. All right, so let me kind of take a step back and kind of walk you through. So if you notice here, if I console log the actual fetch request by itself, it prints out promise pending. So fetch is a method that when you pass it a URL, it returns you a promise. But the interesting thing about promise chaining is that if you return a promise here, you're actually doing a .then on whatever was returned on the previous promise, right? So by default, if you don't return a promise, like if I return 50, this thing is going to just be resolved directly into the next then. Same thing with if I return a promise, the results of that promise is going to be resolved directly into the value here. So that's why if you see here, this is actually like a response object on line 88, but on line 84, this was printing out a promise. So the whole idea of the promise chain is that you can return more promises from the previous promise, and then your next .then is going to have that resolved value for you automatically. So I could continue doing that. Like value is going to be, I'll just say like value of text, because I believe that's also a promise. You hover over that, it says it's a promise of a string. So I can then do like text, and I could just console log the text here. Don't know what's complaining about. I think I have a semicolon I got to delete. So now if I run this, what's happening is we are basically waiting a second. It's going to resolve this first promise and pass it 50. So 50 is going to be here. And then we console log that 50 out, which you probably saw up here at line 1. And then we return a new promise. That promise is going to get resolved here inside of a value in which we have access to .text on it, which again is another promise, which we return. And then the next .then is going to resolve on the value of that promise, which we can print out the actual text. So this is the actual like google.com homepage, like all the HTML that's used for google.com. So that's kind of how a promise chain works. And there's also a .catch. So if you were to have any exceptions happen during this whole process, right? So if I go ahead and just like run this real quick, this won't print out because there's no errors. But if I were to anywhere in this, if I were to go ahead and like mess up this URL, just put some arbitrary stuff here, I believe this should throw an exception, and that exception is going to get caught at the .catch, right? So it never even gets to here, and it never even gets here because this promise actually rejects, and it kind of skips all the stuff in between and goes straight to the catch. And that's why we're able to basically catch any rejected promises. And you can keep on tacking stuff on. Like if you want to do more work after this promise finishes, I could just go ahead and say do more stuff here. Okay, nothing's stopping you. You can keep on chaining on promises to promises to promises, and that's kind of the interesting part of the promise chain, is that you can keep on doing crazy stuff like this. So taking a step back, we talked about callbacks and callback hell and how it became like super unmanageable to write all your code with all these like deeply nested callbacks. And then someone invented promises, and we started using promises because like it's easier to read the code when you have all these .thens that are just chained together, right? Like this, you can admit that this is a little bit easier to read than a bunch of nested callbacks, but it wasn't really good enough, right? So that's why we kind of switched forward to something called async await, right? So async await is completely built off of promises. So if you don't understand promises, you won't understand async await. So it's good to make sure you really have a solid foundation on promises before you start learning async await. So let's kind of take the same code, this whole promise chain, and let's convert it to async await. So I'm going to make a function called main. I'm going to go ahead and put all that code inside of that. And then I'm going to call main over here, right? So this is going to do the exact same stuff. It's going to throw that error, which I should probably go back to like, I don't know, google.com so we don't get errors anymore. And so like, again, like this code's cleaner than the callbacks, but it's still like not it. Like it's still not that great. So people added this async await keyword to functions so that you can actually have your code be synchronous, right? Because right now, it's still all asynchronous. Like this might be called at a later time. Like if I go ahead and just put out a console log here, like zzz, and I run this code, you'll see that zzz is the first thing that prints out, because again, this is all asynchronous code. So sometimes you actually want to wait for something to finish before you can move on to the next steps in the code, which is exactly what this promise chain is doing. It's literally saying, first of all, you need to console log, and then you need to fetch from an API. But we need to wait until we get the results back so we can do something with them. And then we do another promise chain. So let's talk about async await, right? So async await, you just put an async keyword in front of your promise, or I'm sorry, you put an async keyword in front of your functions. And what this allows you to do is you can actually start putting awaits in front of your promises. And that is kind of acting like this promise chain, but it's taking that value and it's putting it straight here. So I can say const value equals await. And now I don't have to do the promise chain anymore. Okay. So it's as simple as that. And now, like, let me go ahead and do that fetch here. So now when I run this code, like, we will get back the value of whatever my promise resolved, which I believe it was like, I don't know. I don't remember at this point. Let me go up. 50. So you see how it still works. It prints out hello world, and then it prints out 1 of 50. So that's the beauty of the await keyword, is that it kind of does the promise chaining, but it removes all of that additional fluff in front of our code so that we can just have this entire block of code wait until that promise is resolved. And then we don't have to do all this promise chaining that gets really messy. So again, like this fetch thing, you imagine instead of the .then, we could just say, you know, const response, and then we could just await on the fetch. Okay. Same deal. Okay. We still have a promise here, right? So value.text is actually going to return a promise. But again, if I change that to response.text, this is still a promise chain. If I run this code, I mean, it's still going to work the exact same way as it did before. But now we're slowly removing all this extra stuff that we just don't care about, right? So again, if we wanted to refactor this, I could say const text is equal to response of text and put that await in front of there. So we have successfully, you know, gotten rid of these promise chains. I'm just going to keep on going down this path because I think it just kind of makes more sense doing this. One thing I do want to talk about, though, is the .catch, right? So when it comes to promises, and when it comes to async await, you don't have the ability to do a .catch on anything because, you know, there's no longer like promises sitting around. So what we typically do is we wrap the entire thing in a try catch, and then we can go ahead and say like we got an error. So same deal, like this. It's just a different approach, but this code is usually a little bit cleaner and easier to read because now we don't have a bunch of .thens and a bunch of callbacks everywhere in our code. So that's kind of how promises work and why we actually use promises now and how we use async await to clean up promises. There are still times that we need to actually use promises and use promise chaining, and there's sometimes that promise chaining just makes more sense. So don't think async await is like the silver bullet for dealing with asynchronous code now. It's just another tool that we can use, and most often, like, this is the tool you want to reach for, but sometimes you don't want to use it. Sometimes you actually need to use promises. You know, one thing I didn't talk about was this reject word. Again, reject is going to basically treat this whole promise as like throwing an exception. So if we go back and kind of reject here and run this code, you will see that it prints out we got an error, because this reject function, when you do a promise, is again basically just pretending like you just threw an error. So sometimes you like have multiple things that you want to kind of do promises on. So for an example, let's say you wanted to run some code that has a timeout, and then you also want to fetch from an API. So let me just comment this code out for right now. I'm going to go ahead and set that back to resolve. So there's some utility methods you can use on the promise class. So for example, one is promise.all, and this is probably the other thing that you're going to use all the time. Like, so if you have multiple APIs you want to hit at the same time, what you can actually do is you can do something like this. Right, so I can do a fetch for google.com, and then I could also just do my promise. Okay, so now I sent an array of 2 promises to promise.all, and when this thing is done, I'm going to get back some results. Okay, so I can do a .then here and pass it the results, and if I print out the results here, this will be an array of 2 things. So let's just run this real quick and see. I have a syntax error. Let me delete that. So run this and you'll see that after every promise resolved, right? So even though this one probably finished in like a couple of milliseconds, this one is still sitting around waiting. So if I actually change that to 5 seconds, you'll see that it just sits here waiting for all of these things to finish. And then finally after 5 seconds, boom, it's done. If you look, we have an array of 2 things. The first thing is the first promise's resolved value. And the second thing is the second promise's resolved value. So I mean, what you can do here, you can do array destructuring and say like number and response if you wanted to, and that can kind of clean that up as well. So I'll just do that, and you can kind of print those out. It's going to be the exact same thing we just saw, but that's kind of, I wanted to show you like why we use promise all, because sometimes it's much faster to fetch all the data at once from your browser and then aggregate it together when it's all done, and then show it to the user versus like fetching one, waiting, fetching the next one, waiting, fetching the third one, waiting. And again, you can apply that same thing I just talked about with the async await here. I could just put an await in front of this. The actual resolved value, I can go ahead and just put to the left, and then I can delete the entire .then here, okay? I'll just go ahead and like log out number just to kind of demonstrate. And if I run this code, it's the exact same code, and it's a lot cleaner to read and understand. And now we get back our results here. Yeah, I don't know if there's anything. There's other helper methods here. There's, I think, the promise.race. I've never really used this one before, but this one's going to basically return the first promise that wins. I don't know the use case of that, honestly. I've never used it in my entire career. Promise.all. I don't know if there's really any others that are worth talking about. Like, I have used promise.resolve and just type in like a word here. So there's 2 methods. There's promise resolve and promise reject. All those are doing are basically just returning a new promise that already has like a resolved and rejected value in it. So you can kind of just use those if you ever need to pretend like you have a promise, but you don't have to go through the whole motions of like creating a new promise and then making it have a callback and then resolving something. You can just do it right here, and it's like a helper function. I've used those sometimes, and they're actually pretty good in like unit testing and integration testing if you ever need to like just make a fake promise. But yeah, so that's kind of the overview of promises. I could get into like the nitty gritty of like promises have different statuses. Like there's one that's called like fulfilled. There's one that's, I have to go to the docs to remember these, but yeah, so there's 3 states to promises. There's pending, fulfilled, and rejected. And those kind of all correlate to the .then would be the fulfilled. The .rejected status would be the .catch, or the, you know, the exception that's thrown here. And then the pending is basically we're still waiting for a response to come back. So you can kind of map those to your like mental model of like pending, fulfilled, rejected maps to pending is like running behind the scenes. Fulfilled would be like this code all runs, and then rejected would be this. And then like I think you could have seen that. Like if I go ahead and print out my promise here and just go ahead and run this code, you will see that it has promise state of pending. So if you ever see that in your console down at the bottom, that is what that means. There's 3 different states to a promise, and it's just showing you the current state. And at some point, like if I were to print this again, for example, if I printed it out here, you will see that it probably has a different type of state. Cannot be invoked without new. Oh, I think I accidentally deleted new here. Oh wait, no, what am I doing? I got rid of all for some reason. So again, like promise pending, and then I believe at this point it'll probably print out promise of fulfilled. Actually, it just shows the value, but just note that that is the actual like internal status of it, I guess. So with all that being said, I did want to show you like how does a promise actually work under the hood, because I think all this stuff is cool, and it's like good to know how to use promises and like how to use promise alls and how do you go from like promise chain to try catches. But like what the heck is actual promise under the hood? Like how do we create a promise? And so what I kind of built out for this little video is this is like the advanced part of this whole video. So it's going to be probably a little bit over your head if you're kind of a beginner. So let me just go ahead and get this stuff prepared real quick, and let me show you what I got. All right, so I basically decided to write my own promise, right? So this, I'm not using the built-in promise stuff that's in JavaScript. I'm using my own, and I made my own class that kind of emulates what a promise does. I don't know if I have all the functionality implemented, one-to-one with how a promise would work in JavaScript, but for the most part, it works pretty well. So we have a constructor here. We have a class called myPromise, and very similar to how we saw it earlier in this video, I'm just constructing a new promise object using that myPromise constructor, class constructor, right? And again, this is giving you back a resolve and a reject. Everything is the same. You have a set timeout, you resolve after some amount of time. And then I got some promise chaining to basically print out when those things are resolved. But if we look at the actual internals of this, how the heck does this work? Well, it turns out the constructor is basically going to take that callback and it's going to invoke it right then and there. Okay, so whatever I pass in here, this is going to get invoked immediately. Probably spelled immediately wrong, but who cares? So then at some point, this set timeout is going to basically fire after 2 seconds. But this is not going to fire. It's going to wait for 2 seconds. So then what it does is it comes down here and it starts running this code, right? It starts chaining on .thens. So how does a .then actually work? If we go back up to the promise, I have a .then method here, and that takes in a callback. And what it basically does is it returns a brand new promise using the resolve and the reject. And we basically set an internal variable or member so that we know what the .then should do when the promise actually resolves. Okay, so I created this method called wrap, and I'm passing it the callback, the resolve, and the reject. And all that does is it basically returns us a function that's going to take in the resolved value of whenever the promise finishes resolving, and we're going to try to call that callback with that value, and then we resolve the output. And what this is going to do is basically allow the promise chain to keep on sending values down the chain, right? Remember, we have a .then and a .then and a .then. This is basically where it's saying take the 10 and pass it here, and then take whatever this is returning and pass it here. I guess it would be like here. Right, so that's kind of how this whole thing is working. And we do a try catch because sometimes these things can throw in exceptions, and we want to catch those and reject the promise when that happens. So we do that for the .then method and the .catch, and we basically just keep on creating new promises and returning them whenever you do a .then or a .catch. Right, so if you notice here, this is actually kind of, I don't want to say it's like a form of recursion, but we are calling the exact same constructor from a method. So we're setting this ._then and this ._catch. When is this thing actually called? Well, remember, after about 2 seconds, that set timeout is going to call that resolve function. And then it's going to go over here and it's going to call this resolve method here, where I had to add the set immediate to kind of push on a function to the end of the event queue. Because if you don't do this, sometimes the .then is not yet called, because remember, this callback is going to be called immediately. All right, so if you don't actually have asynchronous code here, if I just did resolve of hello world, if you don't have that set immediate, everything just crashes because this thing doesn't actually have a .then. In fact, nothing actually crashes. It's just nothing actually gets .then called. So I'm deferring when these .thens are actually invoked, because again, in that situation where if you didn't actually have a set timeout, this stuff would not work. But yeah, I hopefully I didn't really confuse you. I probably did. I'm confusing myself. But that's kind of how a promise works, right? It's just a simple class that has a .then method and a .catch method. Every time you call .then and .catch, you're basically generating a new promise and you're returning it. And that promise is going to take the results of the callback. It's going to wrap it in a promise and return it so that you can basically keep doing this promise chaining stuff. I don't know if this stuff would even work with async await. It might. I could try doing that real quick. I have not tried this, so let's just do an await, and I'll do message is equal to await of my promise, and then I'll console log the message here. Let's see what happens. Hey, it still works. So again, the whole async await thing, I think it's just syntactic sugar for promises. So as long as your thing has a .then and a .catch, I believe async await will just work for it. Which is why, even though I made my own silly little promise class, it still works perfectly fine with async await. because I think I'm still matching the interface that's required for async await. But yeah, I mean, this might have been way over your heads if you're a beginner, but it's interesting to kind of dig into the details of how some stuff works and try to implement your own promise class, because it really shows that you really know a lot about JavaScript if you can do that, right? You understand like how callbacks work and how like asynchronous code all works and how like deferring some stuff works. But yeah, let me know if this was a good overview or if I just kind of confused the heck out of you. But also join my Discord if you want to talk to me directly or ask questions to a community of people who are also trying to learn how to code. Coding is hard and can be very hard and challenging when you're first starting off. So it's always good to join a community of other people and try to like get that help along the way. So yeah, have a good day and happy coding.